Watch for that crosswind. Level it out. Aim for the mountain.
Please remain in your seats with your seatbelts fastened, but give a warm Science on Screen welcome to Dr. Hansman.
All right, thanks. So I normally, when I talk about these things technically, I would give this talk, automation issues and advanced, cockpits. But actually tonight is really my conversations with Otto. Okay. So if you don't know who Otto is, you'll know later. Okay. So if you look at the sort of evolution of cockpits over time, and this is just plotting the number of displays versus time, you see that as airplanes became more complicated, the number of displays increased until the last 20 years or so, the number of displays in the cockpits have gone down. So let me just show you some cockpits. This actually, you can't see it very well. This is a DC-3, World War II vintage airplane. Not much in front of the pilot, about 6 or 7 dials and then radios and things like that. The airplane in the movie, the 707, it's a pretty complicated airplane. You can see that you got lots going on here. What we call a steam gauge flight deck in terms of primary instruments. Here's the engine instruments, throttles, a lot going on in the cockpit. Actually, the most complicated airplane in terms of civil airplanes was the Concorde. This is sort of the peak of the display. It was totally crammed. There was so much going on in this cockpit, it was actually hard to keep track of it. And the only cockpit that's similar is actually the space shuttle, which I don't have a picture of. And then, if you look more recently, this is a Boeing 777. That was the display that was on at the beginning. Things actually started getting simpler in terms of the number of displays because we moved from these analog steam gauge cockpits to computer-based cockpits with the computers driving the show. And things have got more complicated. So I'm just going to take you through one representative airplane. This is the Airbus A320. It was actually the first fly-by-wire commercial airplane. In a typical cockpit, by the way you know whether you're in a Boeing or Airbus airplane is that when in the cockpit, the Airbus cockpits are blue, okay, and the Boeing cockpits are brown, okay. The other thing you know about is Airbus cockpits actually have a side stick, one on either side, and the Boeing cockpits have a central throttle. But you have an instrument panel. This is the pedal stool where the throttle controls are. And on this glare shield panel is the controls for a lot of the automation. The primary display, this is called the primary flight display. In what we had in the DC-3 where we had about 6 instruments, these are all combined into one instrument. So the pilots don't actually have to scan very much. This is your artificial horizon, tells you the attitude of the airplane. This is your airspeed. This is your altitude, vertical speed, compass heading. And this is actually what's called a flight mode annunciator, or what the automation is doing. This is the navigation display. It's essentially like the map that you have, the GPS map you have in your car today. It's actually a little bit simpler. Here's the own ship airplane symbol. You'll have your route on there, and you'll have things like weather in front of you. These airplanes also have many systems. A lot of the systems are integrated. So these are all the key engine instruments are here shown graphically, and then you'll have the system. So this actually page can pull up different systems. The APU is here, or the engine conditions, but it can also be hydraulics, etc. Now we can fly these airplanes different ways in a modern airplane. We can fly the old-fashioned way, manual control, where you use the stick to fly. And actually, modern airplanes you fly through a computer. I'll talk about that in a minute. You can also fly the airplane at what we call the state command level through the mode control panel. So in this case, you tell the airplane, I want to go a particular heading, 350. I want to fly level. I want to climb 500 feet a minute. And then the autopilot will actually, in auto thrust, will actually do that for you. And then we can do something even more sophisticated. We can fly the airplane at what we call the trajectory level. So we can program the airplane from takeoff to landing to start at a location, take off, get to my cruise altitude, go from waypoint to waypoint, get to the destination, land. In fact, in a modern airplane like an Airbus A320, the only thing the pilot really has to do is he or she has to taxi the airplane out, get it on the end of the runway, and press the go button if you programmed it right. Okay. And then when you get to the end, it'll actually stop on the runway, but it can't taxi in from the runway to the terminal. We could probably fix that if we needed to. Okay. Now, the way we control it at these 3 different levels, this is the control display unit. This is actually the keyboard that we use to type in the route of flight. And they originally were going to do it with a QWERTY keyboard, but it turns out that, in fact, on the Airbus display, the reason why there's a side stick was so that they could put the QWERTY keyboard in front of you, okay? But at the end of the day, they ended up using this keyboard, which has become standard in the industry, and all modern airplanes sort of use it. So it's I won't take you through it, but you program in your routes, you press a line select, and you can program in what you want to do. Hopefully you do that correctly. If you're flying the airplane at the mode control level, at the state level, this is on that glare shield right in front of your nose is this mode control panel. And you can dial in the speed you want to fly, the heading, the altitude, and whether the vertical speed, whether you want to go up or down, etc. So this is the way we fly it there. And then when you fly it with the side stick, okay, the side stick in an Airbus is literally a video game controller. Okay, it is just a series of potentiometers. It's not connected to anything. It goes to the computer, and there's actually a complicated set of multiple computers. You can't actually just have one computer, because if it fails, you're in trouble. Okay, it turns out you can't have 2 computers, because if one fails, which one failed? Okay, so you actually have to have 3 computers running the system, okay, on the airplane. And if one fails, the other 2 vote them out off the island, and you're okay. Okay. Now, so we fly these airplanes literally through a computer, which is a good thing because we can now make almost any airplane, like the Boeing 707 in the movie is actually hard to fly. We can make every airplane easy to fly, okay, as long as the computers work. Okay. Now, one of the interesting things on the Airbus, remember I have 2 side sticks. The 2 side sticks are not linked together, okay. So it turns out there's a whole question on how they work if 2 guys are pulling on the stick at the same time. So if both side sticks are being used together, okay, the simultaneous inputs are algebraically summed, okay. So if I want to go down and the co-pilot wants to go up, okay, we actually cancel each other out, so nothing happens, okay. So now if that's a problem, there's actually a button right in front of your nose with the side stick priority button, and you can press the button, okay? Right, so you're taking over from the other guy. It turns out if the other guy presses the button, the last guy who presses the button wins, okay? Right? And then if you press the button for more than 30 seconds, you can release it without losing priority. So that you can see that this can be a problem, and has been a problem in the past, okay? Another nice thing about these modern airplanes is I can actually, I can prevent the airplane from doing bad things. Now, one bad thing that happens in an airplane is something called a stall. If I try to bring the nose up too high and climb more than the airplane can climb, the aerodynamics of the airplane will start to, the flow will separate off the wings, and I'll lose lift, and I'll actually stall. So that's actually what this is showing. This is something called the lift coefficient versus angle of attack curve. So you can keep pulling the nose up, you'll climb more and more, and you get to a point where the wing just can't handle it and it stops. So on an Airbus airplane, they actually have protection. You can't stall the airplane. So if I pull the nose up and I get to the alpha protection, angle of attack from the stick, what happens is that I'll get to the alpha floor where the throttles will automatically go to full power. So if I'm trying to pull up for some emergency reason, the throttles will go to full power and it'll try to climb, okay? Now if I keep pulling back on the stick, I'll get to alpha max, okay? And what that is that's the maximum angle of attack the airplane will go to. If I keep pulling back on the stick, it just ignores what I'm asking it to do, okay? So theoretically, you can't stall this airplane. Now, it turns out you can't land the airplane without stalling it, so they disable it when I land, and it actually has been a problem when it sometimes this capability is lost. I'll come back to that in a minute. The other thing on an airplane like this, an A320, is the throttles don't move, okay? So on most auto throttles, when the auto throttle is working on, for example, a Boeing airplane, the auto throttles will go back and forth. On an Airbus airplane, basically, it's just a video game controller. You put it in there once you're within a certain range, if the autopilot is flying, it just changes the engine thrust and it doesn't move the throttle. So you don't get feedback from that. Now, when these airplanes came into the fleet in the early 1990s, we started having problems, okay? Which was called the mode awareness issue. And it was when the automation executes an unexpected action, that's an error of commission, fails to execute an action that, which is an error of omission, that's anticipated or expected by one or more of the pilots. There are a number of accidents that occurred. I'll take you through a couple of those, okay, in that problem. Now, again, in the context of the movie, this is really issues with Otto, okay, all right. So I'm actually going to characterize these accidents in terms of some of the issues we've had with Otto, the autopilot. Okay, so one is Otto can be opaque. There's sort of a lack of transparency of what's going on. And I'll take you through this accident. This was a very famous accident occurred in the early 90s in Strasbourg, France. The airplane was landing at an airport, and this is a side view of the accident profile. It hit its last navigation fix, and the trajectory that the crew wanted to fly was a 3.3 degree flight path to the runway threshold, okay? So if you actually look at the flight data recorder, what happened, the airplane basically flew about a 3,300 foot rate of descent, okay? Now, how could this happen? Well, remember I told you about that mode control panel? It turns out the same display in the same knob is used to control both flight path angle and vertical speed. The way you change between the two is a little button you press actually right here, okay? Now, the only way you know you're looking at this display that you're in one mode or the other is that if you're in vertical speed mode, in this case, plus 2,500 feet per minute, it would look like this. If it was climbing at 2.5 degrees, it would say 2.5. Okay, so the only thing that's different is a decimal point on the display. Okay, not good feedback. Okay, they have subsequently fixed that, but and one of the challenges you have is that the other place it would show up is in the primary flight display in this climb window here. It would actually be either vertical speed or FPA, flight path angle. This is not a very compelling clue, and we were actually doing research at the time trying to study this class of accidents and whatever. One of the things we ended up working on is something called the trying to improve the mode feedback, which is what we call a vertical situation display. So essentially, this is now a side view of the trajectory. This is the airplane here. And the green line is basically what the airplane will do if you don't press any more buttons, okay? And this display has actually taken a while to get into the fleet, but is now on the Airbus A380 and the 787 airplane. So we're improving the mode feedback to the crew. Now, another problem that you have with these airplanes with Otto is complexity. Okay, Otto's complex. Okay, and he's sort of conditional. Okay, so this actually just shows you. I don't have a lot of time to this, but this is literally out of one of the pilot's guides, and I'll just sort of read it through you. Okay, through the flight control unit, an immediate climb descent is initiated by selecting the desired altitude in the altitude select window, in either pulling the set knob or pressing the level change push button to engage level change mode. Pressing the level change push button also disengages profile. However, if profile is engaged, pulling the set knob does not disengage it. Rather initiates an immediate climb to descent the altitude select in the flight control unit. The exceptions are, okay. So there was actually, a real problem with these systems, and it takes a long while to train on them. And there are some what we call gotchas or traps in these systems. Now, another problem with Otto is misunderstanding. Okay, he sometimes doesn't do what you think you asked him to do. Okay, I'll give you an accident. This is another famous accident. This is now a Boeing accident, just so we're not picking on Airbus the whole night. Okay, so this was an American Airlines flight going to Cali, Colombia. Okay, which is the airport is down here, this little blue area. It's coming in from the north. It went to the Tula navigation beacon. Okay. It was supposed to come in. Now, it turns out this was in the middle of the night. The crew was descending into Cali. At the time, there was a radar, one controller, air traffic controller on duty. The air traffic control radar had been blown up by the FARC guerrillas. So the controller didn't really have a picture of where this guy was, but it was the only airplane coming into Cali that night, or at that time. So the controller asked them if they would like to do, they were supposed to fly all the way down to the south, turn around and land. The controller said, there's no traffic, would you like to land going to the south? They said, that's great. So they programmed in, I don't know if you can read it here, there's a little beacon here called ROSO. So they programmed their computer, their flight management computer, to go to the ROSO beacon, okay? Push the button, okay? And the airplane started a left turn, okay? So, and they're sort of saying what's happening. Well, it turns out the ROSO beacon in Columbia was labeled with, in the database was just an R in the database. But there were actually 2 R's in the database in the vicinity. One was at ROSO and one was actually in Bogota, Colombia, which was to the left, okay? The airplane went to the one that was closest, so it actually turned to go to Bogota, okay? The crew realized this was a bad idea. They turned to the right. Unfortunately, while they were doing it, they had transitioned over these mountains, okay? In the dark, never saw the mountains. The front end of the airplane went over the tip of the mountain and the back end never made it over. So everybody in the airplane was killed. So this actually created awareness of the issue of you really have to make sure that you have the right databases, and they've changed some of the databases. That's been fixed. Another thing that it did is this was actually a class of accidents called controlled flight into terrain, where you have a perfectly good airplane that gets flown in the ground. And one of the things we've done is improve the situation awareness of the pilots by giving them maps of essentially terrain when you go into a terrain area. So this is a warning system called the Enhanced Ground Proximity Warning System, showing you the map on that display and showing you the alerts. Okay, now another problem we have with auto is over-reliance. Okay, and in fact, these problems I just talked to you about came in when we first brought in the automated airplanes. We're having a new class of accidents that's occurring because we have people that have only flown these automated airplanes and actually have a hard time flying them when the automation doesn't work correctly. One example that you may have heard about is Air France 447. This is an Airbus A330. It was flying out of Brazil going to Paris. It actually went through some thunderstorms in the intertropical convergence zone. When it went through the thunderstorms, the airspeed indicating system iced up, and it no longer had airspeed. Well, it turns out the computer program needs airspeed in order to give you all of those sort of good stall protections and things like that. When it doesn't have airspeed, it goes back to a much simpler backup computer program. So it's called the alternate law. But when you're in the alternate law, you don't have the stall protection. This airplane, the crew lost orientation. They started to climb. They actually got into a stall, had the stick fully back, thinking that the airplane would protect them, and never really understood, up until the time that they crashed, that the computer wasn't working right and they no longer had that protection. So this was a disconnect between what the pilot thought was going on and what the airplane was doing, but as an indication of over-reliance. There's another recent accident that we've had, which occurred in 2013. This is a Boeing 777 by Asiana Airlines. They were flying to San Francisco. It was a perfectly beautiful day. It turns out they were doing maintenance on the runway, on the navigation beacon for the runway. So the automation system, which normally uses that beacon, didn't work the way that they were used to. They still attempted to use the automation, misprogrammed it somewhat, thought that it would control the engines for them. It turns out the engines were just in the idle position. They expected to be slowing down, but when they got to the speed that they wanted to do, the engines never came back. By the time they realized that they didn't have enough energy to make the runway and landed just short. So we're sort of seeing that problem. At the end of the day, we're sort of fixing these things, and I actually don't want to say the news is all bad. Okay, these automated airplanes have actually overall increased the level of safety, but they've changed the type of problems that we have, and we're working on trying to design them to give better feedback to the crew and to make the fundamental system simpler. But I just wanted to end with this bottom line story. So this is actually the overall safety worldwide. This is the annual number of fatal accidents per million departures. The dash blue line is the rest of the world. The dark blue line is the U.S. and Canada. And it turns out that, when the 707 was first coming in, things were a little bit sketchy. They have gotten better, and they've continually gotten better. This shows you the past 10 years. And we're now to a level where the level of safety around the world is the same, okay, in commercial jet traffic. We're getting about 0.1 or 0.2 accidents per million departures, okay? So how safe is that, okay? I have a colleague at MIT, Arnie Barnett, who has calculated this statistic. I don't necessarily stand behind it, but this is the way he articulates it. If you were to get in a commercial jet airplane once a day, every day, just randomly pick an airplane, take a flight, okay, in order to statistically be in a fatal aircraft accident, you have to live 40,000 years, okay? So it's pretty damn safe, okay? All right. So, so that's enough for me. I think I think it's time to get serious. Okay. So, all right. Because we're tight on time, I'm not going to take any questions now, but I'll be around afterwards. And if people have any questions, I'm happy to sort of talk about it. So, okay. Thank you.